So the question is based on conduction, right? Question number question number 2. Right. The question is three rods of material X and three rods of material Y are connected as shown in figure. The rods are of identical length and cross section, means same length and same area. If the end A is maintained at 60 degrees and the junction E at 10 degrees Celsius, find effective thermal resistance. Find effective thermal resistance. So you should first take the figure. The figure is having this. There is a rod A, there is a rod Y. This left end of this is taken as A, and at the right end it is taken as B. This is A, this is B. Here, two rods, one X rod and Y rod are connected like this, and here at this point is called as C, and this B and C are the ends of this rod. Here another rod X is connected like this, and here at this end is called as a D. BD is a Y rod. At this end another Y rod is connected. So here between B and D one more X rod is connected. X rod is connected here. This end is called as, this junction is called as E. Right? This is maintained at 10 degrees Celsius and this is maintained at 60 degrees Celsius. So the question is find the effective thermal resistance of this combination. Now we have to consider this is effective thermal resistance of the, just actually just a second. Find the effective thermal resistance. This is point E. This point E, junction E. Here the temperature is 10 degrees Celsius. What is the effective thermal resistance of this combination? You have to understand this. Even this, you have to understand that between, this is something like Wheatstone bridge condition, Wheatstone bridge shape. So if you have these two resistors like P, Q, R, S, and one more resistor is there. One more resistor is there. If yeah, if these are connected to some connection, so that if P by Q equal to R by S, or this P by R is equal to Q by S. R by P by R is equal to Q by S. So any of these conditions, you can consider this concept. These names you can give like this also. Naming you can give like this: P Q R S. If P by Q is equal to R by S, then this resistor, something like you can call it as P Q R S. You can say something different name. Let us give A. You can take R1, R2, R3, R4. This will be some R5. This can be ignored. If P by Q equal to R by S, yes, then R5 can be ignored as no current flows through that. Can be ignored means you can remove that. You can remove that. Same way, if you observe this, they will have identical thermal conductors, identical thermal resistance they may have. So this by this is X by Y equal to X by Y. So you can just neglect this. So in this case, how it looks like is, here A will be here as it is, with the AB rod will be there as it is. The temperature here is 60 degrees, 60 degrees Celsius. But here it looks like um, two, here one X rod and another X rod are connected in series, and here one Y rod and another Y rod are connected in pair. This will be a point E, right? Just you can consider like this also. Consider like this also. They are in series. So thermal resistance of these two is how much? If X rod is having thermal conductivity K, for Y 2K. Is 2K. it is having 2K. This is also a Y only, right? So its use thermal conductivity is 2K. Then what will be effective thermal resistance of the combination? To understand, you have to so just you have to compare like this. And you should remember the thermal conductivity equation also. Thermal conductivity Q is equal to Ka into delta theta by L. So this is actually speaking heat flow. Actually, rate of heat flow dq by dt actually have to take dq by dt. Rate of heat flow is this. If it is dq into T will come. So here, how we have to compare this is the heat flows when there is a temperature difference. When there is a temperature difference, if you compare this with electricity, um, rate of charge flow, rate of heat flow is called heat current. You can call it as H. dq by dt can be taken as H. Same way, a rate of charge flow, if you equate this to I is equal to dq by dt. Rate of charge flow is equal to, according to Ohm's law, I is equal to V by R. V by R, or delta V by delta R. Delta V by R. Potential difference by R. Whenever there is a potential difference in a conductor, then only charge will flow and hence current will be constituted. The same way here, whenever there is a temperature difference, then only heat will flow and hence you get heat current. H is heat current. Rate of flow of heat is called heat current. So if you compare here, in place of potential difference, we have temperature difference. In place of resistance, the entire thing should be taken as under resistance. So you have to write it as delta theta by L by Ka. This is called as thermal resistance. So delta theta. This, let me write it little clearly. This we have to write it as, H H H is equal to delta theta by L by Ka. This part we will take it as delta theta by thermal resistance, TR or thermal resistance. This is, if you compare this with this, the resistance is this. So here thermal resistance is L by Ka. Here thermal resistance. So this writing part is be that clear. Okay. So when comparing this, thermal resistance can be taken as RT is equal to L by Ka. L by Ka. If L and A are constant, you can say thermal resistance is inversely proportional to K. What is this? Thermal conductivity. Thermal conductivity. So we can write it as this. If you want to replace in terms of resistance, resistors are in what do you call series. Effective resistance can be resistance of this plus resistance of that. So you have to take it as with the series effective resistance of this. What you have to understand from this is thermal resistance is inversely proportional to thermal conductivity K. Now, if you redraw this here, one rod is Y rod. Okay, it's thermal in terms of thermal resistances. Let us consider thermal resistance of the Y rod, resistance of Y, and here resistance of X, and in series resistance of X, and here resistance of Y, another resistance of Y. They are connected here. So this is E, this is E. So these two are in series, but the effective of resistance of these two is nothing but between B and E. Between B and E, effective resistance, because they are in series, you can write it as Rx plus Rx. Okay, so 2Rx, 2Rx, but it is inversely proportional to K. We have to take it as thermal resistance between B and E is in terms of they have in terms of what they have given in terms of k and a. Okay, finally they have given the values. So you can take this as you have to take it as let us say effective. Let us consider uh, thermal conductivity, effective thermal conductivity between this is A, B, E, between B and E is equal to actually they will be in parallel to one another. Thermal conductivity is 1 by uh, K, this is K1 plus K2, 1 by K plus 1 by K is equal to 2 by K. So you can say KBE between K and between B and E, effective thermal conductivity is K by 2. Did you understand? Similarly, between B and E, two Y rods are there. Their thermal conductivities are 2K and 2K. Yes, this is between BE for X rods. This is effective ones. Same between BE, effective thermal conductivity for Y rods is 1 by 2K plus 1 by 2K is 2 by 2K. 1 by 2K plus 1 by 2K. So 2 by 2K is equal to 1 by 1 by K. 2 by 2K, 2 by 2K is equal to 1 by K. So this is actually effective parallel combination. It looks like, right? Yeah, because they're inversely proportional. We have to take it as 1 by. So therefore, for Y rod, effective thermal conductivity is K. So you have to, if you replace this, you get Y rod here, and one. What is this? I have to take this as these two rods connected in parallel. Okay, so this is having thermal conductivity of K by 2, K by 2. This is having K by 2. This is sorry, this is having K. This is having K. So this is having 2K. So these rods are in parallel. So yeah, are we considering this thermal resistance properly or not? Cross sequence. Thermal resistance is inversely proportional to thermal conductivity. These two are in a series, so mm, between B and E, thermal resistance is series 2 into Rx or 2 into thermal conductivity will be 1 by K. Hmm? Yes, so it is 2 K by 2 only. Effective will be so 1 by KBE is equal to 2 by K. So it is KB is K by 2 only. Correct. For these two, it is 1 by KBE for Y rods is 1 by K. So effective of this two is K only. Effective of this two will be K only, because you have to consider in case of thermal conductivity parallel combination. Now these two are in parallel, but in terms of thermal conductivities, you have to add this directly. For thermal conductivity part, it will be series combination. So one is having K by 2 value, another is having K value. So one is having K by 2 value, another is having K value. There for thermal conductivities, you have to consider this as direct addition, K by 2 plus K. So it will act like this is identical to 2K, and for this rod, this is A, B, this is E. Between B and E, the effective of this is K by 2 plus K becomes 3K by 2. 3K by 2. 3K by 2. So, and these two are in parallel. Now, between resistors are in series, but thermal conductivities will be in parallel combination. As thermal resistance is inversely proportional, if you consider series resistances are in series combination, effective resistance between A and E is equal to, what is this? It is R is L by Ka, right? L by Ka. So they are in series, right? R1 and R2 having different resistances, let us say R1 plus R2. So here R1 is 1 by 2k. 1 by 2k. For that, another one is 1 by 2k by 3, 2 by 3k. That's why you consider like that in that way. So this is RE. But for this also, if you want, oh, you are asked to find thermal resistance only, right? So in that case, you can directly take this. I'm simplifying this further. We'll get 6k, 3 plus 4, 3 plus 4, 7 is 7k, 3k square is 7k. So we'll get 7 by 6k is this one. So as a result, you can write the thermal resistance between A and E is equal to 7 by 6 into k is, now we have to replace this is k. Directly I have taken like this, 7 by 6k. They have given in terms of L and A, right? So thermal resistance, actually it is a thermal resistance. So actually should be thermal 7 by 6 into I have to take L by Ka. I have to take, actually this should be, I should take this as R something like this. The rotation. Here R1 plus R2. I have taken this as 1 by 2k plus 2 by 3k. Right? So this in terms of thermal conductivities only I have taken. Directly proportional relation I have taken. Otherwise, if you have taken this full form, yeah, because they are having identical lengths and areas, right? So if you have taken full form, what you will get here is R A between A and E is R1 plus R2. R1 should be L by K 1A K1A plus this is L by K2A. So here L by A, if you take out common, then whatever this will get, this one only. That is that 7 by 6k. So it is equal to 7L by 6k, 6A. K is also here. Yeah, 7 by 6 Ka. So the thermal conductivities you have to just replace, and you have to compare with identically resistant thermal resistance. This one. So the question is, a potential barrier V volts exists across a PN junction. Okay. The thickness of the depletion region is D. The electron with velocity V approaches PN junction from N side. The velocity of the electron crossing the junction is. So what I have to consider here is noise consider. In general discussion, otherwise just let's consider here only in general discussion. So what you have understood here from this third one, right? Potential barrier V volts exists across PN junction diode. So there is PN junction diode. PN junction diode is a junction P-type and N-type materials. N-type materials are there. Potential barrier exists here. This is a potential barrier. So its potential is uh, value of the potential barrier potential is V volts. V volts. The thickness of the depletion region is D. The thickness of this depletion region is D. An electron with velocity V approaches p-n junction from inside. From inside, electron is approaching. Electron is approaching means if we connect this to forward bias, P region to positive terminal and N region to negative terminal, then this negative, positive, so this will push these electrons this side and hence it will approach us. An electron with an electron with velocity v approaches p-n junction from one side. So electron is approaching with velocity v. With velocity v is approaching this junction, p-n junction. The velocity of the electron crossing the junction is. So this is the actual junction. It is having some potential barrier. So this entire junction is having a potential barrier. So when it is crossing this, what should be the velocity? Okay, I have to say that initial velocity with which it is approaching is u is equal to v. What should be the final velocity? So that the potential barrier voltage is v and it is having a thickness of d is the question. What happens, we have to remember here one point that whenever any charged particle is passed through some potential, it gains some energy. And energy is called potential energy when it is passing through some potential. And if an electron is passing through a potential difference of 1 volt, energy gained by that will be taken as 1 electron volt. 1 electron volt. Whereas here you can say that when that energy can also be taken as work done. Okay, so here when this electron passing through the potential difference, the barrier potential is nothing but potential difference of V volts, then energy or work done is equal to force into displacement, or in terms of potential you can write it as this work done is nothing but energy gained by this. You can also take it as energy, kinetic energy, or kinetic energy gained by the particle is equal to charge into potential difference. Charge into potential difference. Charge of the electron will be E. Potential difference is given as barrier potential is V. Okay, and this is the energy gained. What energy? Kinetic energy gained. Okay, but that energy you can also say there is a relation between potential electric field generated due to this potential and D is electric field. They are not related with the electric field, right? So anyway, electric field is equal to V by D. V by D. From this you can say V is equal to ED, but we don't need, I think, this here electric field part, but potential can be force. This is equal to work done. So you can say it is nothing but the force into the displacement. So the displacement is nothing but the thickness of the depletion region, but this force is electrostatic force. This further we can write it as EV is equal to force is what do you call this? Force is in electric field, right? Force expressed by the electric field is QE. QE means here E E into D into D. The velocity of the electron after crossing the junction is. So to understand that, we have to instead of considering this in terms of this, we need acceleration to find out what is final velocity. I have to say that it is moving under uniform acceleration and hence uniform force. So we have to replace this in terms of FD. It can be expressed as it is force acting on a charge, which charge electron. So it is nothing but as because force is equal to mass times acceleration. And if you replace this here, mass into acceleration into d. Alright. From this, acceleration can be expressed as uh, ev by m into d. This is the acceleration which is experiencing by the charged particle on crossing this. So if with this acceleration it is going, with this acceleration if it is going, starting with initial velocity v, what should be the final velocity is the question. So we have to use an equation called v square is equal to u square plus 2as relation here to find what the final velocity we are asked to find, right? It is equal to u is v square, and here you have to understand that what kind of force it is experiencing. Whether it is experiencing positive force or negative force, retardation will experience, right? So it is positive means it is negative, it is pushing here, but it is when crossing the barrier, its velocity will decreases. So that means it undergoes negative acceleration. So I can express it as minus ev by m into d. What is this? V is u. Sorry, u is v square minus e, 2as, right? So 2 into a is ev by md into s is nothing but d only, right? So this if it gets cancelled out, so here the final velocity, let us take it as some v dash. So v dash square is equal to v square minus 2ev by m, because dd can cancel. So this further on simplification we get final velocity v dash is equal to square represent here, it becomes square root of v square minus 2ev by m you will get. Square root of v square minus 2ev or ve by m you will get. This will be the final velocity on crossing the junction. Right? This one. Yeah. So this is the third one in 87. Right. So the question is, a PN junction diode when forward biased has a drop of 0.5 volts, which is assumed to be independent of current. The current in excess of 10 milliamps through the diode produces large joule heating which damages the diode. If we want to use 1.5 volt battery to forward bias the diode, the resistor used in series with the diode so that the maximum current does not exceed 5 milliampere is. So the given data you have to chop out very carefully. So what is given here is there is a PN junction diode. PN junction diode which is connected to the battery of circuit diagram. Given this given circuit diagram, let us try to draw, and again let us observe the question. And it is mentioned that it is connected to a resistor R, and this diode having P region here and N region here, so that it's what is mentioned here is it's a forward bias drop of 0.5 volts. We call this as what you call barrier potential, 0.5 volts, and this battery is having 1.5 volts, 1.5 volts, so that it is positive and negative terminals. The question again, if you see, a PN junction diode when forward biased has a drop of 0.5 volts, a potential um, drop of 0.5 volts means we call it as um, barrier potential of the diode is this. Means if you increase the potential, the input potential, even you can observe this with the help of Heeat characteristic graph, IV graph or VI graph. If potential is increasing from 0 to 0 0.1, 0 0.2, 0 0.2, 0 0.4, something like 0.5 till 0.5, current will not increase. That is the meaning of it. So beyond that, current increases, and it will shows the drastic change, the IV characteristic behavior. Now the question is, in a PN junction diode, when forward bias has a drop of 0.5 volts, which is assumed to be independent of current. This is independent of current. Okay. The current in excess of 10 milliamps. The current in excess of 10 milliamps is called forward biased current. Okay. Diode current or forward biased current is almost 10 milliamps. 10 milliamps. In excess of 10 milliamps through the diode produces a large Joule heating effect which damages the diode. If the current is more than 10 milliamps, then it will damage the diode. Okay. If we want to use a 1.5 volt battery to forward bias the diode, 1.5 volt battery, 1.5 volt battery to forward bias the diode, the resistor used in series with the diode so that the maximum current does not exceed maximum current. Maximum current should be 5 milliamps is. So what you can understand from this is question number 7, right? Yeah. What you have to understand here is when you have because its current potential is 0.5 volts, when you connect to a battery, even though its potential is 1.5 volts, till zero point 0.5 volt is reached, there will be no current. That means in this 0.5 volts will be wasted in overcoming this. Then how much potential will be used to draw the current here? 1 volts. So the resistance from Ohm's law, this of course, even if you apply the Ohm's law, V is equal to IR, V is equal to IR, and hence R is equal to V by R. Delta V is equal to actually delta V. So it is here delta V is potential difference is contributing the current in the circuit is okay I delta V by I, R is equal to here I. So to get the maximum current of 5 ampere on applying connecting to 1.5 volt battery, 1.5 minus 5 volts will be acting over there. So what is the then potential here? 1.5 minus 0.5 is giving you a current of 5 milliamps. Milliamps 10 power minus 3 amps. So 1.5 minus 0.5 is 1. 1 by 5 to 10 power minus 3. If you bring it here, it becomes 10 to the power 3. What is this? Resistance. Ohms. 1 by 5 is 0.2. So why is it putting at minus 3? This one, it is milliamps. The current is given as the maximum current should be in milliamps. SI unit of resistance is ohm. To get that, everything else will be in SI units. Delta V SI unit will take it as volt, and that for current is ampere, not milliampere. So I have to convert milli ampere into ampere. That milli is 10 to the power minus 3. Milli means 10 to the power minus 3. So that 10 power minus 3, if you bring it to numerator, it becomes 10 to the power plus 3. So 1.5 minus 0.5 is 1. 1 by 5 into this is nothing but 1 by 2 is 0.2 into 10 to the power 3. Or if you multiply with 1, it will get 2 into 10 power 2 will get, otherwise 20 to 10 power 10 by 10 if you write this can write the other way differently. What is that? We get 200 ohm. So options, based on the options, you can see 2 into 10 power 2 that here. So 0.2 into 10 power 3 can be expressed as 2 into 10 to the power 2 ohm. That will be the resistance, this resistance. That implies R is equal to 2 into 10 to the power 2 ohm. That will be the corresponding. Okay. Question is given little confusing way. So just do that, you have to understand if you come across this kind of questions how to deal with. So just you have to understand that what you have to understand is in PN junction diode when forward bias it has a drop of this means this is nothing but the drop in potential, whatever the potential will give that will not be used for conduction. So that means after overcoming this only conduction will take place. That is the meaning of it. We can call it as a barrier potential also, which is assumed to be independent of current. Okay, and the current in excess of 10 milliamps through the diode produces large Joule heating effect. If it is excess of 10 milliamps, it will produce what you call Joule heating effect. Okay, there is actually not needed, but confused I have given this now. If we want to use 1.5 volt battery to forward bias the diode, the resistor used in series with the diode so that the maximum current does not exceed 5 milliamps. This much you will use for to get this much maximum current. What should be the resistance? resistance in the circuit. That's it. Okay. This one. Equivalent distance between A and B. Options are given like 36 if A is greater than B, 18, 0, 0 in this case and this in this case. So what we have given here during the, that's it. Okay. So we have to consider these conditions. If VA greater than VB, what happens? If VA less than VB, what happens? So what is going here? Question number 12 is the equivalent resistance between A and B or AB is the question. So that's for the figure. The figure is having a PN junction diode and resistor resistor of 36 ohm and here another resistor of 18 ohm and the diode and here another PN junction diode PN junction diode we are having and this is these 2 points are connected. These points are connected to points A, this is A and this is B. What is the effective resistance between A and B is the question. Okay. So what you have to understand here is if you connect this to a battery, imagine you are connecting to this to a battery so that it is higher potential, this is lower potential. If this is higher, this is lower, that means the potential here at A, if you take it as VA, if you take the potential at A is VA and B, potential B is VB. However, if VA is at higher potential, means positive potential or higher potential, is if VA is greater than VB, then so VA is greater, and greater means it will be positive potential, yes, this will be at higher potential, yes, that means this will conduct, this will conduct, this also will become positive forward bias, this will conduct, and this also will become forward bias, this also will conduct. So as they are conducting in forward bias, whatever because of this, if some current draws, that entire current will flow, they flow through this, through this, and through this, and through this, it will come out. So what is mentioned here? In that case, if it is conducting, then resistance between A and B, then there will be no resistance. If A is greater than VB, A is greater than VB, or AB will be equal to 0. Right? So, yeah, that's just if you have understood this. The other case, you have to consider this is like the other way. What is that? If VA is less than VB, so it will not conduct. It will not conduct, but it is no resistance is given here. What you have to consider this is these two are said to be. This is something like this is only one resistor is here. This will not conduct means it will act like a point. It will not conduct. Okay. So what you have to consider in that case is this is not conducting means you have to say the current will come here and pass through this. Yes, when it is coming here, when it is trying to pass through this way, right? So because this also will be, because it is connected, this is lower and this is higher. This will be reverse biased. This higher means this also will be reverse biased. First of all, this is reverse bias. This will not conduct. Hmm? So this is positive, negative, and this is negative, positive. Then what you can say that is there is when they are not conducting, the only positive, negative. This is negative, positive, right? This will become reverse bias means this will be negative, this will be positive. This is positive means this also will be positive. So this is positive means this will conduct. So whatever the current comes here, this will conduct. So it will conduct and pass through this. This is where the conducting path. So it will these resistors will be considered in series combination. If VA is less than VB, then if we take these diodes D1, D2, D3, D1 and D2 will not conduct, but D1, D2 will conduct. D1, D3 will not conduct. So D1 and D3 will not conduct, but D2 will conduct. So resistors acts as connected in series. Resistors acts as connected in series. So resistors will behave like in series, like in series or series combination. So therefore, effective resistance RAB is equal to 18 plus 36 is equal to how much? 54. 54 ohm. Okay, that's it. So VA is less than, it will be 54. For a transistor, the current amplification factor is constant. Transistor is connected in common emitter configuration. The change in collector current when the base current changes by 6 milliampere. Question number 15. Page number 85. So the question is a transistor current amplification factor. Current amplification factor can also be called as gain. Okay, output to input, that is represented as beta. It is how much? 0.8. Common emitter. Common emitter should be more than one. Actually, common current amplification factor. Okay. Okay. The transistor is connected in common emitter configuration. The change in collector current. Change in collector current can be taken as delta IC. Delta IC, change in collector current. The change in collector current when base current changes by 6 milliampere is when base current delta IB is equal to 5 milliampere. What is this? So we know that in common emitter, beta is nothing but output current by input current. Common emitter is output, emitter is common, collector is output, base is input. So delta IC by delta IB will be, IC is given as, is not given, IC is given as, IB is given as, not 5, okay, 6 milliampere, okay, 6 milliampere. So I have to take it as delta IC by 6 milliampere is equal to, this implies this is equal to beta, beta is 0.8. So delta IC, there is to find delta IC only, right? Is equal to 0.8 into 6 is how much? 4.8 milliampere. All finished? The change in collector current when the base current changes by 6 milliampere. The transistor is connected in common emitter configuration. For a transistor, the current amplification factor is 0.8. 24 milliampere. Current application contains usually consider series commands. So current gain in according to this transistor, we need to consider alpha. They are not mentioned. Initially, it will come in base configuration. It is in that if this is alpha, we cannot take this. We have to find beta. To find beta, we have to use manipulation. So it is not mentioned that the current application factor in common base configuration is 0.8, then we have to use it. Maybe some printing mistake is there, but we will cross check once.
So can you explain this concept around how the given downstream or
This boat moves perpendicular to the bank with velocity of this. A current carries it 150 meter downstream. Find the velocity of the current. The width of the road. Yes, we are winding the session. Actually, this question there is some data is wrong. So actually, actually, according to the given question key, it is supposed to be this. Means you have to use this beta as alpha. Then only it is possible. So that the data is not given, we'll cross check and we'll take it. If it is alpha, then you have to take one relation between alpha and beta is equal to alpha and minus alpha. Then you have to find this. Then substituting this, you'll get delta IC should be equal to 24 milliampere. Otherwise, if the given one is beta 0.8, then you will get this one. So this is correct. For this to be correct answer, the given value should be alpha. We'll discuss this once again.